Hey guys, this is the Unit 5.1 Systems of Equations lesson. So our TEKS today are A3F, A3G, and A3H. We need to be able to learn, we need to know how to, by the end of the day, be able to graph a system of equations. We can use Desmos for that, be able to find the solution to that system of equations. We'll learn what that is, and then also be able to determine how many solutions we have, whether it's one, none, or infinite. All right, so now, a system of equations, we have to know what that is first. A system of equations is two or more equations. In Algebra 1, we only deal with two equations at a time. When you get to Algebra 2, you'll start dealing with three or more. And so the solution to the system is where the graph of the equations intersect. So if you look at these two lightsabers up here, imagine those are linear equations. They're going to intersect right there at that point. That would be the solution to that system. There are three different types of solutions that we could find. So when we're graphing, you can encounter three possibilities. The first one is one solution. In other words, the two lines are going to cross. They only share one point, and that'd be the point where they intersect, just right here. The other option is that they would never intersect. They would be parallel. And so in that case, we would have no solutions because they have no points in common. They're not sharing any points. And the third one would be infinite solutions, and that's the exact same equation graphed on top of each other. That means all of the points they share. So an example of a one solution on this would be the point 1, the 3, 1. We go to the right 3 up 1. They're only sharing 1 point, that point 3, 1. That is my solution. And on this one, we know that we would have no solutions because they don't share any points. And here we would have infinite solutions, meaning that every single point is included. Okay, so now it's helpful to know that if you look at the two equations, you could tell. If you recall back from lesson 3.4, the parallel and perpendicular lines that we were writing, you should know that if you have different slopes, that you know there's going to be an intersection of some kind. No matter what the slopes are, if you have two different slopes, you know you're going to have only one solution. Now, if you have the same slope but a different y-intercept, then you know that's going to be no solutions. Okay, that's going to be two parallel lines. And we talked about parallel lines having the same slopes but different y-intercepts. And then the third one would be infinite solutions. So that's when you have the same slope and the same y-intercept, right? And so that means it's the exact same equation. All right. So now when we look at these two right here, obviously I'm going to have one solution. I'm going to have one solution because I have different slopes. I have a slope of 3/2 and I have a slope of 1. And since those are different, these two are going to cross. Now I am going to show you how to graph these on paper, and then I'm going to show you how to use Desmos, and the rest of the problems today, we'll just use Desmos. And so remember, to graph an equation, we start with the y-intercept. I'm going to start at -4, and then I'm going to use my rise over run, 3 over 2. I'm going to go up 3, to the right 2, and graph my line. For the second equation, I'm going to plot the y-intercept at -2, and then I'm going to use my slope, which is 1, it'd be 1 over 1. I'm going to go up 1 to the right 1. And then I'm going to keep going up 1 to the right 1 until they cross. And you would notice that they cross right here at this point, and that's the point 4, 2. So the solution to this system of equations is 4, 2. I have one solution at this point, 4, 2. Now, let me show you how to do this on Desmos, because that's probably going to be the easiest way to access this. And so let me make this just a little bit smaller so I can get everything on here. We're going to type both equations in. Y equals 3/2 x minus 4. And the second equation is y equals x minus 2. So I'm going to put both those equations in there. And then the cool thing I like about Desmos is once you put those in there, I can literally just click on the point. And then I know that is my solution, 4, 2. All right, so very simple. The only problem is if you try to graph an equation, let me turn these off for a second. If you try to graph an equation like they give it to you like this, 2x plus 3y equals 12, we're in standard form. It won't graph these for you. It will only graph it if you have y by itself. And so remember, we learned how to solve for y on these. We've been doing it all year. You're going to have to solve for y on some of these to be able to answer them. Okay, great. So let's get to the second one. You should be able to look at these two graphs and understand that these are parallel lines. They have the same slope, but different y-intercepts. And from recalling from prerequisites, the previous lessons we did on parallel lines, you know these are parallel lines. But I want to check Desmos just to be sure. And so I'm going to go in here and I'm going to type y equals 2x minus 3. And on this one, I'm going to type y equals 2x plus 1. Graph those two equations. Let me turn them on. graph both equations, you can see that these are going to be parallel lines. No matter how much we zoom in and out or move the graph, they are not going to intersect. They're not going to cross. And so these have no solutions. Okay. The next one's a little tricky because remember, we cannot put these into Desmos like this. And so we have to be able to solve for y. And so what you would do in this case is you're going to take both equations. I'm going to take the first one, 2x minus y equal 1, and I'm going to solve for y. We always get rid of the x value first and bring everything down. I have negative y equals negative 2x plus 1. Now this is understood to be a negative 1, and so I could divide everything by negative 1. And now I'm going to have y equals negative divided by negative is a positive, and a positive divided by negative would be a negative. And so there's my first. I'm going to put a y1 here. That's my first equation. Now we got to do the same thing for the second one because you got to get y by itself on both of them. And so I would get rid of the x like we always do. Oops, sorry about that. Get rid of the x like we always do. Well, I don't know why it's doing that. I'll move it over a little bit. And so you're going to have negative 3y equals negative 6x plus 3. And then you would have to divide everything by negative 3. Now we're going to have y is equal to negative 6 divided by negative 3 is a positive 2x. And 3 divided by negative 3 is minus 1. And so now when you look at these, they did not look the same, right, in this form. But they end up being the exact same equation. And because they're the exact same equation, if I was to graph those in Desmos, I'm going to show you, I know this is common sense, but I'm going to show you that it is the same equation. If I do 2x minus 1 and I do 2x minus 1, you see that those are the exact same equations graphed on top of each other. And so they have infinite solutions, Okay, great. So I want you to, now the other thing they can ask you is they'll say, determine if this point is a solution to the system. Anytime they do that, you're still going to plug it in Desmos. And so I'm going to go ahead and type in y equals 3 halves x minus 4 and negative 2x plus 3. And then when I do that now, I can go ahead and type that point in. Remember, we can type a point in and graph it. So it's going to be 2 comma negative 1. When I plot that point in there, it's showing that it's right here. Is that a solution to the system? Yes, because it's a solution to the red and the blue. And so since it's on both lines, it's where the intersection is. That is a solution to the system. Now, to determine if the solution on a table, if they give you a table and say, what's the solution to this system? Remember, it has to be the same point. They're going to give one x and two y's. So this is the point 1, 2, and the point 1, negative 1. That's obviously not going to be the same point. So when I look down here, I've got 4, negative 10, 4, negative 10. If the y's are the same there, then you know that is the same point. It's the point 4, negative 10 would be my solution. Okay, now you try this one to see if you can get it. Tell me what you think the solution to the system of equations of this table would be. Okay, if you said that the solution would be negative 12, negative 11, then you are correct. They're sharing that point. Okay, now let's look at the next one. So that's it. That's it. That's all that they're going to ask you to do. If you can practice getting y by itself, and then you can practice, you get y by itself, and then also be able to put it in Desmos and understand what a solution is. And this is a very easy lesson to do. So once you go do your practice, you start checkout and your ticket out the door. And then if you need tutorial help, please come help. We're going to continue doing graphing throughout this unit. I'm going to show you the other methods so that you see them, but really we're going to focus mostly on getting y by itself and graphing these in Desmos. All right, you guys have a great day.